See, good afternoon to everyone. So today we are going to discuss what is data science. See here, just what is data and what is data science. So in data science, we are going to extract the data. We are going to extracting the data. So we are extracting the data and then we are taking insights from the data. We are taking insights from the data. So we are extracting nothing but what ma? We are extracting. What we are extracting? The data. Just we are separating the data. We are separating the data. At the same time, we are taking that separate the data with key points. What are the key points will be there in the data? We are going to extracting. So that is data. So is there so much amount of data? So from the data we are extracting what are the key points. So with this we need to work on large amount of data sets. So for example for example we are taking DMART. DMART as a example. So in DMART, for example, we are working for 1 year. So they are working for 365 days daily. But 365 days they are selling large amount of data. So for example, they are selling large amount of products. Simply we will take for 365 days into per day 1000 products we will consider. So then what is the amount of data? 3,65,000 data there will be. So with this 3,65,000 data, we are going to work. So first we need to work on the CRISP-DM methodology. We are working on the CRISP-DM methodology. With this methodology, we are going to work on the data science project. How the data science project will work? We need to take 6 steps. We going to take 6 steps. In these 6 steps, how the data science project will work, how the machine learning will take the positions in that particular project, how the deep learning will take the position. We are going to check one by one. So first one is about business problem understanding. Business problem, business problem understanding. So in this business problem understanding, as a data science project we are working, the first priority is client. Who is the client? Is the most preference we are giving to their. So and then the client requirement, and the client requirement is also most needed. So we are working when we are working, so we need to take client decision is very important with the requirement of the client. So we need to work on both data with the client requirement. What the data we are going to take, the data is giving by client with the requirement. What he has requirement, he has selling to us, and we are taking that requirement. We are going to work on that particular project. For example, now we are taking DMART as a client. So DMART has given previous 1 year data. But that 1 year data, where they are losing, which the products are not selling best, and which products are going more. So in this way, we need to check the data and we have to fulfill that client requirement. So from that this decision, we are going to take first step as a business problem understanding. So in this business problem understanding, we are going to learn the data. We are going to learn the data, which the data was given by the client. So we need to learn the data, and then the second point is about collecting the data. Collecting the data from different sources. From different sources, we are going to collect the data. It may be company's database will be there, or else from search engines like Google, like we are going to check that, or else it is not possible from client database, company's database and Google or like search engines. So we are going to check client database too. Client database too we are going to check. So here what the data we are going to check. So what the data was given by the client, we don't know. We have no idea about 100% of data. So first of all we need to check the 100% of the data, full clear and clarity. So then only we need to work on the data. So without knowing the data, we are going to work on this particular data set. It will not give a good prediction. So first of all, we need to work on the data. What the data was given by the client and what the requirement of the client, we need to work based on that. So first we need to learn the data. So then we are going to find that what the data we don't know. For example, we have idea only 60% of data we have idea. So known data is 60% and unknown data is 40%. So unknown data. So without knowing here 100% data, we are going to predict on the data. So it will not give a good prediction. So you see we know 60% of data here. So we can proceed with the data. No, we can't proceed. Why? Because here 40% of data we don't know. So what we have to do? First of all, we learn that 100% of data. If it is not possible, we need to take company's database or else search engines like Google, etc., or else client database. So gathering information from all these, we need to make sure we need to have 100% knowledge on the knowledge on the knowledge on that particular data which was given by the client. We need to make 100% clear particular. So then only we need to proceed with third point, that is exploratory data analysis. It is very important. Exploratory data analysis, CMA, this is very important. Why? Because how the prediction we are doing, that depends on the EDA. So nothing but EDA is nothing but what? Exploratory data analysis. It is very important for getting good prediction. So prediction nothing but we are getting good accuracy based on pre-processing. So here pre-processing we have different steps. So nothing but the first one is data cleaning. So we are working on the data. So we need to clean the data. So cleaning is nothing but we have different techniques like SEMA. So here in data cleaning we have missing values. So we have working on the large data sets, like we have right now we have 3,65,000 data. In this 3,65,000 data, they have large amount of missing values. At the same time, we have duplicates, repeated data may be possible because the number of workers will be changed daily. So we have large amount of data, and with the large amount of employees, there is a mismatches of the data. So we have missing values, duplicates, wrong data type too. Wrong data type, wrong data type, and very important is outliers. There will be a chances to getting outliers in the data. So these all things we need to work. So one by one we need to work on the real time data. So we are working on the 3,65,000 data. There is a possibility of getting these all. Maybe see here duplicates is not a there is no problem, but wrong data is not a problem, and wrong data type is also not a problem when we are finding the accuracy. But the missing values and outliers will affect on the accuracy. So based on that, we need to take care of all these things while getting best accuracy. So at the same time, the second one is about data wrangling. So nothing but what ma? Data wrangling. Here also there are different types like CMOX ones. See, in data wrangling we have feature transformation, feature scaling. Third one is encoding, and fourth one is discretization. See, earlier we are using all these techniques in pre-processing the data. So while getting 100% data we have right now, 100% of data we have, but the 100% data what we have, there is no exact data. So there is possibility of missing values, there is possibility of duplicates, there is a possibility of wrong data or the wrong data type too. At the same time, there is a possibility of getting outliers. So here we have 3,65,000 data, but the data is not full-fledged. So here we need to check the data and we need to clear the data. While clearing, the data wrangling also takes a major role. So here the data wrangling is used to for converting one format to another format, one format to another format is called wrangling. So what we are converting? Data. We are converting one data type format to another data format. So we are working on the data. So we are converting data format. Data format. So this conversion is called data wrangling. By using feature transformation or by using feature scaling or encoding discretization, we are going to treat all these things by using data wrangling. So which the data we are having, there is a possibility of getting object type data, object type of data, at the same time int of data, and there is a sense of float of data. So these type of data will be there. So based on the format of data, type of data, we are going to conversion. So while converting the data, we need to use feature transformation, feature scaling, encoding, discretization based on our data. So here simply while you are using machine learning, the data will be in different formats. See, the cost of price will be different, the cost of item is different, and the cost of price is different, and the various aspects, the data which were giving in the data set, particular data set, it may be changes. So based on our need, we are going to change the data and we are using for the prediction. So as well as a data scientist, our need is to predict the data. So that prediction, we are going to change that particular amount of data which is needed for us, and we convert the type of data which we required. So at last we are getting 100% pure data, 100% pure data. Now in the data there is no missing values, there is no outliers, there is no wrong data, there is no duplicates, and the conversion of data is fully pledged completed. So after this pure data, we are going to apply train test split. Nothing but train test split is more important. Train test split. So here we have 100% of data. While going to predict on some data, the client requirement is totally different. Why? Because you are predicting some data, 100% of data you have, you predicted on that data. While you went to client, he will ask just where is the proof? Show me the proof. How we show the proof? By taking the test prediction. The proof is nothing but test prediction. So we are 100% of data what we have, we are separating that. So we are separating the data, particular data. 80% of data we are going to give for training. We are going to give training, and 20% of data we are going to give for testing. And here one thing is the data, what the data we have 100%, we are not separating directly. You need to take from 1 to 20 as a train data, from 20 to 30 is test data. We are not going to take. By randomly it will take the data. It will separate the data randomly. We are separating the data randomly. After applying train test plate, the train data and test data will be separated randomly. For example, we have 200 data points. Data points is 200 points. So here we will not take it as a from 1 to 40 for test. We are not going to take. We are not going to take here. Why? Because the random data, it will take randomly. We are not going to take like this. If you take like this, it's not a need of for getting a good prediction, and we will not take a particular data we will not going to take. That's the reason we are going to separate the data randomly. So it will take The test data we are taking, it will take first or 30 or 40, 100, 200, any randomly data points it will take, random rows it will take. So your random rows will be taken. After that, the fourth one is modeling. The fourth one is modeling. In modeling, we have machine learning, machine learning, deep learning, NLP, all these things, different things will be there. So here we are going to take, again, we will take AI also. So why? Because the different data will be there. So here the data is separated two types: structured data, unstructured data. So structured data will be somewhat different and unstructured data is somewhat different. So supervised machine learning, unsupervised machine learning, how it works? Again, the structured data, unstructured data is also different. So your total structured data will work under machine learning. Structured data. Example is Excel. Example is Excel. How the Excel sheet will be with rows and columns. Will be rows and columns. Same, the data which we are working on the machine learning will be in same format. So the data what we are getting, it may be in structured format. Like Excel sheet, how it will be there, rows and columns, that type. So next is unstructured data. Unstructured data. Unstructured data nothing but all the data which we are using, deep learning, NLP, AI, all this under unstructured data, means there is no structure, there is no structure, there is no format. So this type will be there, like for example, audios, videos, images and text. All these while we are working on the deep learning, NLP and AI advanced. So with this we don't have any structured format. Now I am taking the class. If I prepared for this structure, I need to prepare this and I need to tell this format only. I need to talk this, I need to talk this we need to know, no need to talk in the class. We are not going to discuss all things. Or the flow is going, it is unstructured. So but in structured data there will be a format, means there is a class timing, at the time of class will be start, at the time of class will ends, and what the topic we are going to discuss, this all under structured format. Okay, unstructured format there is no structured format. Why? Because the data which will be there, it is not in the formatting, so it is unformatted data like audio, video, text, images, etc. So of this, majorly we focus on the accuracy. Our focus is only accuracy. So we are getting a good accuracy, so then the prediction is very good. What the prediction we have done, that is very good. So here what we are using, total our prediction is depends on the accuracy. So here majorly we will take train accuracy. So already separated data, you know that 80% of data we are selected for, 80% of data we are selected for train accuracy, and we are selected 20% of the data for 20% of data for test accuracy, nothing but 20% of data. So here one thing is about, there is a chance for getting 100% accuracy, but we are not finding in train accuracy or test accuracy, we are not going to find 100% of data. So but we need 100% of data to get a good accuracy. So what we need to do here, just we need to check the cross validation. So cross validation nothing but what the data we are separating from the train data and test data, it is nothing but we are taking 20% and 80%, and we are not going to take any 100% of data. So just we are going to take here 100% of data, nothing but we are cross validating, we are rechecking that 100% of data. So in this 100% of data, we are going to check total data. So now the train accuracy is important, test accuracy is important, at the same time the cross validation is also important. For example, I need to find these three accuracies. So when the three accuracies will be taken here, the best form we need to take is just nothing but, see here, when we are going to predict a model, there is a chances of getting good accuracy or bad accuracy. So for getting good accuracy, we are getting good accuracy, so we are using different algorithms. There is the chance for getting good accuracy, and some algorithms which will not perform a good performance, it will not give a good performance. So then there is a chance of getting bad accuracy. So we need to check that both accuracies. For good accuracy, how we will predict? So we have done some accuracy and we will get some good accuracies. So for example, the train accuracy we are taking 80%. Say sorry, 80%, why we need to take 90% we will take. So I got 80-90% of the accuracy on test train, and then I got 93% of the accuracy on the test. While I am doing cross validating the data, when the cross validation, I got 93% of accuracy. So here, is this good model or bad model? Is this good model or bad model? It is a good model. Why? Because it will get 90% and above. It's not a matter. It's not a matter. It will getting 90% or 100%. So for example, we will take another example too. So here I got 100%. Okay, and again I got test accuracy 100%. Again in cross validation I got 90%. So here also good accuracy. So this is best accuracy or this is best accuracy. So here 100% will be there now, 90% also will be there. So this is the best accuracy. No, this is not the best accuracy. This is the best accuracy. Why? While we are taking the data, we are taking cross validation is equal to some amount. Like I will take 5. If I take 5, we must take we must take the difference between the train test cross validation is less than 5%. So if we need to take the cross good accuracy, then we will take less than 5%. When the difference will be there between train test and cross validation, train test and cross validation, the difference when will be there less than 5%, then only we will say it as a good model. See here, I have taken 90%, 93%, 93%. So overall the difference is less than 5, but here the difference is more than 5, nothing but it is exactly 10%. So the difference is more, so we will not take it as a good model. So here it is a good model. So the difference between train test cross validation is when the percent is less than 5, then only we will take it as a good model. So if the difference is greater than 5, if the difference is greater than 5%, it is a bad model. So we have done bad performance. So we need to recheck the model, or else we will need to change the algorithm. We need to apply another algorithm. Okay, so we need to check another algorithm. After that, getting the accuracy, we are going to fifth point is nothing but evaluation. So evaluation nothing but what we are taking the data what we have done up to modeling, and the next is evaluation. So evaluation nothing but we are rechecking, evaluating. So for example, in real time we are working as a team. In the same, we are working on same project. So in this same project, we are getting different accuracies. We are not getting same accuracy. We are thinking is different. We are applying algorithms is different. we are applying total, the project is different. So then the same project we are applying different patterns. So in these different patterns we are getting different accuracies. In different accuracies in different algorithms. So we are rechecking all our colleagues with the what the projects they have worked and how the accuracies they are getting. We are rechecking in our team and we are finalizing the project. We are finalizing the project, and that finalized project we are going to submit to the client. So that is nothing but presentation. So we are doing the presentation to the client. So we are going to check that particular. So at last, in presentation we are submitting our project to the client and we are taking total the prediction what we have done, now we have worked, what our prediction, now we need to means how the project you need to apply on the real time. So we need to submit all our presentation with our project we are going to complete this, and then the client will take our project and he need to implement on the real time. So with these 6 steps we are going to apply, and this we call as a CRISP-DM methodology. So these 6 steps we are using in the data science, and it is methodology of CRISP. So by using these all things, we need to check all these things, then only our project will be completed. So all these things, the major thing is we are knowing the data. The knowing data is major important, and the data we are collecting and then we are applying on the pre-processing and then the modeling and the accuracy we are taking. All these come on order, which the we are taking the order. We all these things we are going to apply. Okay, so here we are taking machine learning just structured and unstructured. Here there is number of algorithms, and here going number of algorithms like regression algorithms like simple linear regression, multilinear regression, polynomial regression, all these regressions, and in classification also there is number of algorithms, and applying all these algorithms we have getting best accuracy, then only we are taking that as a prediction. So that best accuracy which algorithms we are getting, the data which we are separating for train and test, the test data we are applying the prediction, then only we are finalizing the model, this is good model or bad model, then the client we are submitting our project. Thank you all of you. If you have any doubts, please contact me.